All right, welcome everyone. So now we will have a next talk, and we have Vicky from KodaDot, and he will be talking about interoperable NFTs in Polkadot ecosystem. So thank you for coming, Vicky, and stage is yours.
Yeah, thanks. So welcome to the presentation. As Peter mentioned, thank you for the intro. I'm Vicky Val. I'm the co-founder of KodaDot and the technical wizard in our company. And like any implementation or integration, I'm usually the guy who is thinking about the architecture. And you can find me on the GitHub at VickyVal and everywhere on the social networks too. And question is like, who's familiar with KodaDot? Already raise your hands. If you have merch, perfect. So KodaDot is open source NFT marketplace in the Polkadot ecosystem. And our main thesis is we are multi-chain powered. So we already support Polkadot, Kusama, Asset Hubs, also Basilisk, and EVM such as Moonbeam and Moonriver. We are technology agnostic, so it means we have 6 standards on 9 different chains. And what it means that for user, it basically shouldn't matter if it runs EVM, if it runs runtime pallets, or if it runs WebAssembly. And we have a bounty-based system, so we have a really small internal team of developers who are making all this possible, and the others are paid by the small bounties. So we are bringing the dev talent to the Polkadot ecosystem. So anybody can go to our repo, check our issues, make a PR, and they are automatically paid. And we have already like 500 stars, almost 300 forks, and more than 120 contributors so far. And the question is, like, what's the current state of NFTs in the Polkadot ecosystem? And there are many chains which have already installed like pallets, these like plugins for the substrate chain. And there are many such as like NFTs, Unique's ORML NFT. And there are many chains which already implemented that, such as like Basilisk, Asset Hubs, Fala, Unique Network, and many others. There are then smart contract based, which we can name as a EVM or WebAssembly, and the most popular ones are like Moonbeam, Moonriver, Astar, Aleph0. All of them have some sort of smart contracts, and there are sort of legacy NFTs, which dates before like any pallets or something like that. Is the strings in the chain, and they are living on the Kusama, such as like NFT graffiti, let's call it. And to integrate them all, we tried back then, like 2021, the really naive solution to fetch and transform the data, like the raw RPC calls, onto the front end, so through hackish decentralized way, from the RPC node to the client. But there are a few problems. Like first, you have big and slow front end as a result. So when the user is waiting for the response from the RPC node, it takes a while. Then to transform the data to readable format on the front end takes also a while. And you basically store a lot of data on the client's device. So after a time, the user's device becomes unresponsive, and basically most of the devices just kill the app. And plus, the bad feature is like many lines of code have to handle like specific implementation. So there were many like, if the chain equals asset hub, then do this or else, and it creates like big mess in the code base. And what's the like current architecture of KodaDot? First is the front end, which is powered by state-of-the-art Next in version 3. It's really fast, and we use composition API, so it's really easy to read, and for developers it's easy to extend. Then we have sort of services, which are basically Rust-based workers, so we don't have any centralized server, so people don't need to rely on some server such as like pinning the data or something. Everything is based on these external microservices, and they are distributed across the globe. So when one fails, the second one can pick it up. Then we have sort of backend, which is like FireSquid indexers powered by Subsquid, and they expose the GraphQL API, so the core, like how data flows to the front end. And then we wrote a ton of open source packages for minting, for utilities, how to transform the data into the correct or unified format. Actually, there are like 4 different NFT standards even in the like Polkadot ecosystem. So To transfer them into one readable format, it took a while. And then also for the rendering, so you can do the conditional rendering if you decided, okay, when someone logs into your app, I want to show different picture. And that's what we support. And also the main core is also Polkadot GS, so people can interact with their own wallet, with the Talisman, Polkadot GS wallet, and many others. And okay, the question is like, okay, why do we need indexer? As I said previously, we do not want to sacrifice the user experience. So reading the data, as we know, is very slow, takes a lot of time and a lot of resources. Also, when you use indexers, you have great opportunity to make analytics. So you can make data views and get a great insight for the data. So as you see on the picture, there's actually flippers on the collection from the last year's decoded. So you see that people are actually trading. There is some volume going on with the collection, and people try to list it for a really high price, such as like 21 Kusama. It's quite a lot. And then like events in general are not persistent, so you can either catch them or not. And plus, the subscript itself has a really simple GraphQL interface, so you don't need to rely on some sort of REST API. You can get from the GraphQL what you really need. And like, I don't know how are you familiar with the indexers, but how do they work is basically in Substrate there are two types of data in each block. It's events and extrinsics. Of course, there are a lot more, but in general, these are two which are like fetched. So extrinsics are the calls that the user making, such as NFT create, and you create NFT in the collection. Then you have events, so basically some sort of data structure which is emitted on the chain when something happened or the chain state changed. And then rule of thumb is basically it's more effective to process events. They are faster and they are easier to make if you have enough data, of course. If you need more, for example, from the extrinsics, like specific settings per NFT collection, of course, query that. And this is how our data structure looks like. There are many clients using the KodaDot indexers, such as like our custom CLIs, KodaDot. There are also Sub0, which is using that. Then via GraphQL, we are fetching the data from the indexers, and the indexer itself actually fetching the data either from subscript archive or the RPC nodes. And like you can ask, like, how do we model data in KodaDot? It's basically 4 types of data. First is the collection, then the NFT, and then the others. So you can imagine collection as a sort of smart contract in the context of EVM. So basically any contract which is like type of ERC 721 on 1.5.5 in WebAssembly is PSP34. It's basically collection. So it holds sort of like data such as like version, so 721, name, what's the current maximum for that, who created that, and what are the metadata and other like side data such as like what was the block number when it was created. Then we have like an NFT entity, which represents the NFT itself, like the token. So in general, it has also like name, if it's transferable or it's soulbound, then for which collection does it contains. Also the issuer, so if you have like open collection and where anybody can mint, you should have this data like, okay, who really created on-chain the NFT, and also like other like hash or metadata. So you can see the image of the token itself. And then actually someone asked me yesterday, okay, Vicky, but can we get some listings from the marketplace? Like when someone listed the NFT, how can we read it from KodaDot? There is actually another type, which is called event. And basically any data which are connected with the NFT are stored here. So if you want to fetch the listings, you basically are checking for the event of interaction of list. When you want to see buy, it's also the same. So it's an event of the type buy, and in the meta attribute, there's stored the current value for which particular person bought that. And also like the current owner. So if you bought the NFT, the caller is the buyer, and the current owner is from who you bought the NFT. And of course, we store metadata entity. So that's the metadata of the NFT itself, because we first had a problem with the NFT metadata. That when client tried to store all of them, fetch all of them from the IPFS itself, it creates us like huge bill for the IPFS gateways, and also people were overfetching these NFTs. So you fetch them once and store forever. And we can try to fetch some data. So how does it look like with the GraphQL? I'm not sure how much you are familiar with GraphQL. Okay, so let's do that. So we have here the node playground for the asset hub. So I can make it bigger. So as I promised you, there are a lot of these magical entities you can query. And to query the entity, you select the query, then the name. We don't need to do that now. Then the parameter. So we're gonna fetch ID. And what we wanna do is asset hub Polkadot. So we want to fetch the collection. So it's collection entity by ID. And now we pass the parameter, which is like variable from the query variables down there. I can make it bigger. By ID, easy. And now we want to maybe get ID, name of the collection, and block number, let's say, or created at. And now you see that the first NFT, which you have minted yesterday, we have stored on our GraphQL gateway. So we have name of Polkadot, then the block number, and when it was created. So it was created basically a week ago. So they were prepared. And perfect. So as you can see, or you have seen, the Sub0 expose like really nice playground. So you can first make your own query, and offers like easy GraphQL interface. And we have also special resolvers to expose the data analytics. So this is like query if you want to get collection entities, which have some NFTs which are non-burned, and then get another like 2 NFTs from each collection. And what we found out is actually a really interesting one, that people have a problem with the GraphQL. And that's it. Like many front-end developers, when we started with the bounties, they said like, okay, we can do front-end, we can manipulate the data, but we never played with GraphQL. And for us, it's like hard to use, hard to learn. It takes like a week or so to get into touch with the schema, how does it work, and how to play with the GraphQL itself. But for most developers, especially when they come from non-Web3 environment, for them it's hard. For them it's like really hard to understand, like, okay, this is the collection. Collection has some NFTs. NFTs has some events and so on. And we wanted to create something like it's easy. That you don't need to have this knowledge of Web3. You need to have knowledge of GraphQL itself, like something really easy, so you can hack with KodaDot like right away. And that's why we create like API. And in its core is basically a query builder on top of the Sub0. And we offer 2 implementation. First is the builder pattern, and second is the REST, like the fake REST API. And the point, or like our unique case of our API, is that there is no middleware server. Like as a Alchemy or any other API provider, we don't track your data. We don't track what you query. We don't rate limit you. Like you are a free person to build on permissionless system, and that's also one of the core theses. And it's easily extendable. So when you come up with your own query, like, okay, I want to implement this, you just fork, build, and you are free to go. And it's easy to use. It's basically 3 lines of function. I'm trying to like convince everyone, okay, like you can start with Uniquery in 3 lines of code. First is like to import, second one is to create the client, third one is to fetch, and you are done. So 3 lines of code and you are done. And basically, there are already like 40 calls already out of the box, which we found out in KodaDot that, okay, this is needed to start with some basic UI, and many also are coming. And as you see, there is a special NFT from our Sama collection, which is called Toku NFT. And if this presentation was interactive, it would be actually view component, which was already like load it. And so why is Uniquery so cool and why I'm like super bullish on that is that on the left side, you can see like the query from the GraphQL. And okay, you want to NFTs from the particular collection. So you need to use, okay, name it, like NFT list by collection ID. Then you need to query the NFT entities. Then you need to learn how to write the correct like syntax for the GraphQL. So where collection ID equals and so on. And the second thing, every like GraphQL client has different data structure, so you need to always learn how does it work. And then when you try to fetch like basic data such as like ID, metadata, and owner and the creator, it takes quite a time to learn the query or write it by yourself. Whereas like on the other side, you have the Uniquery, which is basically as I promised. You have import, and using the builder, you call the get client, select like which ID you want to select, and then you call basically client dot item list by collection ID, and it's done. And you fetch it, and it's done. And also using REST API is even simpler. There's like path to specify, and you basically ask for the data, and it's done. And what does the API do? I was trying to reverse engineer and learn like how GraphQL works on the inside, and I found out basically like GraphQL server is basically waiting for one endpoint, which is post with a path of query, and it requires one query body, and the body contains also two fields, which is like query and variables. Like as we learned before in the query playground, we specify the query. And down there was the query variable. So the same is required by the server itself. And the best thing is that the schema validation is always done on the side of the server. So if you make invalid query, the server tells you, hey, like this is not a valid query. Please give me one. And this is why it's not like good query. And that's why we also make the Uniquery itself. It always composes like correct queries with the builder. And it's already out of the box for Node.js, Web, Dino, and also Bun, which was released a week ago. And the best thing is, it's not a big package, such as like Polkadot.js, which has like 2 megabytes or something. It has like 56 kilobytes to ship, like CommonJS, which was used by Node, and the ESM for most of other browser, plus it's properly typed by TypeScript. So you can see, like under the hood, what we are doing when you have, for example, querying the collection by ID. You have the ID, other fields, which we say about it later. And basically, we make the build, the collection of the ID type, and that's done. So you return always the correct query. And the question is, like, where is the documentation for this package? And the answer is, like, no, the code is self-descriptive. Like as the person said, like last week, that they are removing TypeScript from their app because no one needs it. Our code is actually like self-descriptive, and it's really easy to understand. Of course, there is some README, but the code itself is easy to understand, and I tell you why. And the first is the naming of the calls. Like usually, people or the developers itself have the biggest problem not to implement some feature, but to name variables and name the functions so they make logical sense. And that's why we call with this like simple approach. We have the 4 main entities, as we learned. So it's collection, item, event, and metadata. And the naming should be like logical and self-descriptive, even if it's verbose. And I'm really inspired by Hibernate itself. It's a Java ORM. And the naming pattern is really easy. It's like entity, expansion. So if you need like to expand this query with something else, and then when you want to filter, it usually calls by which field you want to query, and if there is another field you want to use, it's and the other fields. So if you see the example, I imported the query client, create the client, and then okay, I want to entity of a collection by ID itself. That's it. If I want NFTs, which list of NFTs which are in the particular collection is like item, it's a list because it's more, and by the collection ID. That's it. And especially also why I call it expansion is like you can use the count query. So how many NFTs are in this particular collection? And it's like item count by collection ID. It's like simple, easy to understand, and people can build on top of it like super fast. And same also works for the unified response. So I didn't want that people, okay, fetch the data and now what, like to check like what's the return state of each NFTs. We have still the same for entities, and the response pattern matches almost the same pattern as the request. And the naming pattern is simple. It's like object, which contains one field, that's called data, and then the name of the entity. So when I want to fetch item, this is like item by ID. So item data by dot item. If I query collections, collection list is data dot collection list. That's the same. If I have a count query, for example items, it's like data dot item count. So all the things make like logical sense, and that's like really nice. And plus, the best thing, there are batteries included, and you may ask at this point, like, okay, we came for this talk to talk about multi-chain and not some like query builder. And that's like where the get client, like really where was function takes sense, because get client function takes like chain prefix as an argument. So basically to create like fetch from the other chain, it just swap the prefix. Like we have a chain which is called AHP, is asset hub Polkadot. If I wanted to have asset hub Kusama, I just swapped chain with AHK, and that's it. And now it works multi-chain, simple as that. And also, if you don't know what the prefixes are, we have everything is TypeScript based, so it actually your VS Code tells you like, yeah, this is available chains. And if you don't have VS Code and you're a hardcore like Vim user, you can still like say, okay, I want to be the client is the bottom line. That get client that AHS could be something, and then you get error simply from the Uniquery itself, which tells you, oh, this is not a chain, and I don't find the chain which has prefix AHS, but there are any allowed values, and it tells you like, okay, this is the allowed values. So you've learned, okay, I maybe made typo in AHS, and it's like AHP. And there is also already the fetch function. So back then I was hacking without that, and I was like, okay, this is bad. Nobody wants to play with that. So I implemented like the fetch function. So when you make query, you pass it as a argument to the fetch, and then you get the result. Simple as that. And also like we have a ton of friendly errors, so you can make mistakes basically. And as I mentioned previously, everything is super typed. And of course, like list functions has an additional options, as you can see. It's a limit, offset, fields, and burned. So by default, like first version of Uniquery, we're giving you all the data. Even the NFTs were burned, and people were telling us, okay, this experience isn't good. We want just to have real NFTs, which are non-burned. So you can select like, okay, I want also to have burned NFTs in the call, so I can show it. But by default, it's turned off. And of course, we have the limit, offset, and you can also extend fields. And by default, Uniquery itself does not overfetch the request, because many times people, when they make their first query, they don't are looking for the exact parameters like where, this, or limit, or offset. They just would like to call it all. And sometimes it can happen that your collection has like 10,000 NFTs, and the subscript would have a hard time to fetch it. It would be like really big request. So Uniquery does not overfetch the data. It's like minimalistic by default, but you can always extend it. And there is a function extend fields with image, for example, or with the animated media or the price or something else. So it extends the default set with another fields. And of course, like extend fields, it's fully typed, so it gives you, okay, for NFTs, you can have another field such as image, such as price, such as hash. And when you swap the call with the collection list, you get different set of two fields which you can extend. And package is, yeah, as properly typed as GraphQL, and you can always know what to fetch, so you don't need to check the documentation or trying to debug some stupid mistake for many hours. And that's why you cannot make a bad request, and that's like our main goal. And everything, as I mentioned previously, is bounded by default. So the list functions are limited by 100 items. And why so? As I mentioned previously, like people love to overfetch the data, especially if they don't know how to use the GraphQL properly. So we limit it to 100 items. Like we can expand it any time. It's basically constant in the code. But you have always possibility to check the number of the results via the counting queries, and the counting queries are super fast on the Postgres thanks like to optimizations we made. So you can count the client.item count by collection. You get the result, how many collections, and then you can see the data that item count that total count, and that's it. So you know like how many calls you can make and how much you should paginate. And this also fake limit should keep your app performance. So if you overfetch the data, the app gets slower and slower and slower. So you should optimize also on that. It also happened to us that suddenly we were making like 2 big paginations, and the client was super fast. Also, like the bigger you paginate, the more it takes for the subscript to give you response. So make it lean, make it fast. And yes, you won't kill subscript when you have like ultra big collections. And we have a lot of time actually, so I want to show you a small demo because the KodaDot itself like is a huge application. It has like a lot of lines of code, and I built something which is called Fandom, and it's based on the Dino. Yes, which is called Dino, and you maybe know that Dino is the JavaScript runtime, something like Node.js, but written in Rust, and we love Rust here. And it's Butter included runtime, so it means it's fast, safe, and built-in tooling. Also support with TypeScript and JavaScript extension, which you know from React or something like that. And there is a web framework called Fresh that ships zero JavaScript when you don't need that. So by default, it's like ultra fast, and you can enjoy the performance and good CO score. And this uses React by default. It's a smaller version of React, which is also like super fast with the same API and a lot of libraries which are already compatible. So let's check it. I turn cute. So there is a repository in our code base. It's called KodaDot. In our code GitHub under the fandom. I can share the link later. But to start the Dino, you just make the Dino task start, and bam, in seconds the app is running. So we can open that in Chrome. Boom. So as you see, as example, I took the collection which were already a lot of you were minting into. And it's simple app written in Fresh. It's ultra fast and already has pagination included, so I can show the right demo. And yeah, maybe Damsky has NFT here or not. Sasha has here, so he writes just Polkadot Sasha. And yeah, as you see, the app is like super simple. There is already pagination done, and still works fresh. Damsky NFT, easy. Sub0 vibes, good shit. And let's check the code, how does it work. So index.ts. Okay, so should be big enough. Can make it bigger. So first you can see there are a few imports what are like required by the code itself, but as you can see on the line 11, there is the import of the KodaDot, which is like, as I said previously, get client. It's like usually you start with that and the extend fields. So what I'm doing next is basically creating the client based on the chain I set in my environment. In this case, like it's AHP, so Asset Hub Polkadot. And the collection I want to fetch is the collection ID number 8. You can see these numbers in KodaDot. So you just copy it from the URL. And now, once we have the client and the collection ID, we can check how does it work. So first, what we are doing, this is handler for fresh, and it doesn't do the fetching on the client side. It's using the edge, so very performant serverless function, which fetch the data really fast, also catch the responses. And first, like, we check the URL, what's inside of that, and then we make the count query. So I want to know, like, how much should I paginate for this particular collection, and it's called done. Like, we created the client for the asset Polkadot, and then I said, like, okay, item count by collection ID, and pass the collection ID, and then I call it on the line 38. We add the query and the variables, and that's it. I get the response. So you see this result, that item count, the total count, as I said previously. And then I know, like, how to paginate, like what's the variables. And by default, I also set like 12. Okay, so if user doesn't set the pagination itself, like, let's use 12, so it's fast. And then I paginate, like, okay, how big offsets should I create? We add the page, and it's like calculate. There's the basic logic basically of the pagination, that you have a limit and offset. So offset by 10 items, and then you fetch another 10. Easy. And then basically once I have, like, how should I do the offset, is I create call it the client dot list item list by collection ID. So I want NFTs from these particular collections. And I want to extend basically the fields with the meta, which is the array object of metadata, so such as image, animation, URL, description, and so on. And with the price, so I want to show the price of the NFTs. And then I limit the query itself by the items per page. If I skip it, I would get automatically like 100 items. And then I call it on the GraphQL. This is like old syntax which I use. That's why I created the fetch function on the client, so people don't need to write this. So they just basically call the client.fetch and pass the query itself. And then there is renderer. Once I get the data, it renders the function. So now this is like the tailwind code, which basically create all the products, as you see, and fetches the items. So yeah, so each element you see here, or not. Yes. So each element you see here is basically the product, and I show the name, I show the price, and I show the image. Basically, that's it. And that's how it works. And also, if you click on this item particular, you can check the code for that. So it's basically, when you check the URL, it's a product and some ID. And now when you see the Telegram VS Code, you also have the handler, and you say like, okay, I want the client, also create the client without the parameters. That means that I want to have like universal query. Like, I don't want to be opinionated about the standard, but if I pass it the chain, it's okay. And then I have the also get function, call the client.item by ID, pass the parameter from the URL. And also I said, okay, I want to extend also these fields with meta and price. If I want to just get rid of price, I can do that. And if I want something else, you see, it's already TypeScript powered. So I can choose like, okay, I want serial number, why not? I want name. And the best thing is that it's really safe and dummy proof. So if default set has already name included, and you extend fields with another name, it would crash on the GraphQL. So we try to make it already unique, so you can fetch the same field twice, so it won't crash on the GraphQL. And now when I have it, I can do this. I can do console log here. Nice. So now when we check the console, see the first thing is the data dot item, and then I see all the items. So we fetched already the serial number, we fetched the name, which was by default, and you see the price is missing. If I added the price there, it would work the same. So see, the price is already there and it's 0. So these like really nice things about Uniquery, and if I do something bad, the client itself tells me. So if I pass the string to the parameter item by ID instead, if I pass number instead of string, it will tell me like, okay, you can parse this because we expect string on the GraphQL endpoint, and you pass the number, so it will fail. And using the Uniquery is like really easy to build anything you need, and it's really nice. Like you see, like in few lines of code, you have full pagination, full data view, and also like full item ID, and it's easy. And what's the like future of Uniquery? You maybe ask. We try to make it like more customizable, so you can bring your own indexer. It was kudos to Sasha who came up with that. Like, okay, what if I want to make our own chain? I will follow your NFT standards, but I want to use like, for example, fandom shop with it. So I have like first like universal frontend for the NFTs, and like this is also what we are working on to have it more customizable, but on the other hand, not to break the compatibility with Web or Dino. Also, we are trying to bring more chains, so better support with the EVM, WebAssembly, Ink, and also Solang. And many analytics resolvers are coming. So we have first data such as series insight or hot flips. We try to bring like these analytic resolvers also with 3 lines of code. So you basically fetch the data and done. And also we are happy if you bring your own idea, even in the form of the open issue in the Uniquery repository, or you raise a PR. And also, as we are bounty based, the bounty is included. So you can get some tokens. And of course, don't forget to visit KodaDot XYZ and click the follow button on x.com/KodaDot. And I have one more special thing for you, because you are here. You may already seen this special QR code yesterday on the party, and you can scan it, and it opens the special website, which is called pub.koda.art. And the secret thing why I'm telling that is that it was completely built by the Swell and Uniquery, thanks to the Hladikes, and he basically made it in a matter of week or so to have fully this working app. And it's like really nice that you can build any app basically for the NFTs with the Uniquery. Like if you fetch the data, transform it something you need. If you need like token gating, you can still fetch it. If you need, for example, to check if this current wallet has the NFT from this collection, you can do. You get the response, you can transform it, and basically you can get the response you need. And it's easy to build. As you see, it's 3 lines of code. And we are also working on the hosted version of the Uniquery. So if you use any different language, such as, for example, like Swift or Kotlin or something like that, you can use the fetch function in your own language. Plus, there are many other developers already building like alternative flavors for the Uniquery. This is like currently TypeScript package, and there is already a guy from Polkadot Blockchain Academy who hacked the C# version and won the grant. So I'm really happy for that, and looking forward to visit another flavors of the Uniquery itself. And yeah, don't forget to claim this pub. If you have no wallet, you can visit the pub.koda.art, and the code is wiki Sub0. And the special thing is just claim it fast, because I limited the collection to just few items. So claim fast while it's hot. And I'm happy that you joined this talk. What are your questions? Thank you.